Hey there. Hey there, this is Reuven Lerner. I am delighted to be presenting here at BellPie, and my talk is how to sort anything. So first of all, a few words about myself. I teach Python to companies all over the world. I have courses about Python, about Git. I offer a set of courses called Weekly Python Exercise. I recently published a book called Python Workout with Manning, and I have a free weekly newsletter that goes to about 20,000 developers around the world each week called Better Developers. But let's talk about sorting. And let's face it, sorting is actually important. But sorting is one of the things that we do most actually with our data. And why? Well, we want to display it nicely. We want to make messy data maybe a little less messy. We want to find the largest or the smallest value in a collection. Maybe we want to see which products sold best at our online store, or we want to see which products sold worst. And you can see I'm getting more and more practical and more specific with my examples, so they'll maybe ring true with the work that you do. Which supplier's proposal will cost you the most? I want to find out which is the closest gas station to my current location. I want to find films similar to the ones that I just watched. And maybe I want to find products similar to the ones that I'm looking at. So if you want to sort in Python, the best way to do that is the sorted built-in function. It's not a method. There is a sort method on lists, but you really should not use that. You should use sorted. It works with all iterables, and it always returns a list, sorted from lowest to highest, at least by default. And it does not modify the source data at all. So how are we going to use sorted? Well, let's say I have a list. My list is 10, 5, minus 3, 7, minus 2, and 4. And I'm going to now print the sorted of my list. Well, as I said, we're going to get a list back, right? So I'm going to print here after my list is. And so we're going to get a list back, minus 3, minus 2, 4, 5, 7, 10. It is sorted indeed from lowest to highest, but that is the list that we got back. The original list has not been changed at all. See, I promise. Now, how is this being sorted? What sort of algorithm is being used here? Well, it was invented by someone named Tim Peters, and thus it is called TimSort in his honor. Now, TimSort assumes that real-world data contains what he calls natural runs. And natural runs means that within the data, it's not completely scrambled. There are always going to be a few little areas in which it's already sorted. And so TimSort merges these natural runs together. And if there aren't any, then it uses insertion sort to add them. So in this way, you can think of TimSort as being a mix of merge and insertion sorts. Okay, so let's get a little more practical here. Given items A and B, we will need to know which is true in order for TimSort to do its thing. Is A less than B? Is A greater than B? Or is A the same as B? And when it's merging or inserting, TimSort is going to rely on this comparison. If we have a sequence of numbers, then we can just use Python's less than, greater than, and equal operators. And we saw that earlier. So what if I want to sort a list of strings though? Here, words equals, and here I'm going to set up a list of strings using split. This is a bunch of words. And if I print the sorted of this, sure enough, I get a list back. A bunch is of this words. Now, how does this work? Well, think of it this way. One character strings can be compared with less than, right? You can know that it's checking the Unicode code point for this one character string or for this character. Well, what happens then if we have a multi-character strings? Well, then we're going to check the characters at index 0. And is word 10 less than word 20? Great, then word 1 comes first. How about word 10 is greater than word 20? Then word 2 comes first. That's easy enough. What if they're same though? If they're the same, then we try again with index 1 and index 2 and index 3. And if they're equal, then just return word 1. Doesn't really matter. Now, that's right, if one is a substring of the other, then return the shorter string. Now, if this sounds familiar, then it's probably because you've looked up words in a dictionary before, right? This is how we search for things in a dictionary. We look at the first character, then the second character, the third character, until we find the word that we want. And this way we can know which goes first or second alphabetically. Well, it turns out this same algorithm works on all Python sequences. If you have a list of strings or a list of lists or a list of tuples, it's great. So if I want to compare a list of lists here, so list 1 is 10, 20, 30, list 2 is 10, 20, 15. So is list 1 less than list 2? False. Why? Because that 20 in the middle. Is list 1 greater than list 2? True, because again of the 20 in the middle. Now, lists can contain different types of them. I know, according to Python convention, that's not a good idea, but they can. What happens if we try to sort a list containing different types? Well, actually, it's going to blow up on us. That's going to blow up saying less than is not supported between instances of str and int. You can't actually compare. What does it mean to compare a string and an integer with a less than comparison? Well, let's try something else. What if we want to reverse the direction? Instead of being from lowest to highest, we are from highest to lowest. Well, then we can just use the reverse equals true parameter. If we set the parameter value to true, then suddenly we're going to get it reversed from biggest to smallest. What if we want to sort a list of words, but by their word lengths? So we no longer want TimSort to compare word one and word two. We rather want TimSort to compare the length of word one and the length of word two. Now we don't want to sort the lengths, right? We don't want to get a list of integers back. We want to use the lengths to sort the words. So the way we're going to do that is by passing a value to the key parameter. So if we have a function f, right, then we want to compare f of a is less than f of b. And then what we can do is we can call the sorted function with key equals f. Notice, f here is a function and we are passing it as an argument. And because we want to sort the words by length here, we can just call sorted with key equals len. Let's see how this works. So I'm going to say here words equals, this is a bunch of words. Okay, we're going to split it. Now we have a list of strings. And now I'm going to say print sorted of words, key equals len. This is the, so to speak, key thing. And what's going to happen now is TimSort is going to apply the len function to each word. It's going to get those lengths back and use the lengths to compare them rather than the words themselves. And sure enough, now we get them from smallest to biggest. So what can be a key function? What can we use for this? Well, any function that takes a single argument and returns a value that can be compared with less than. Basically anything comparable. So what are some examples of this? Well, I can do sorted on words of key equals len, what we just saw now, sort words by length. I can say sort of numbers with key equals ABS, absolute value. So this will sort numbers by absolute value. It'll ignore whether they're positive or negative. We can say sorted of words with key equals stir lower. Now we can sort words ignoring the case because all of them will be forced to lowercase when we compare. Now you can also notice here that we can pass a method by passing it as a class attribute. So we're not passing the lower method on a particular string. We're passing stir.lower, which can be applied to any string. Now, don't actually execute the key function. I see this mistake all the time. It's really common to use parentheses after the function's name. So what you would maybe think of doing is saying sort of numbers key equals ABS parentheses. Don't do that. Instead, what you want to do is say sort of numbers key equals ABS. Now, it's not going to work if you do it with the parentheses right off the get-go because ABS actually needs to get an argument. But you have to actually pass a callable. You have to pass a function or class to key. ABS is a function, but the result is an int. And we can't really pass an int because then the int has to be called. In any event, you want to pass the actual callable, not the result of invoking the callable. Well, what if I have a list of lists or a list of tuples? I want to sort them by length. Yeah, I can just use key equals len, just like with strings. What if I want to sort them by the sum of the numbers, the sum of the sublist or of the subtuple there? Well, then you just say key equals sum, and the sum function will be applied to each of these sublists, and then they'll be sorted by their sums. But here's the thing, we can also pass custom key functions. We can pass our own functions. The function takes one argument, all right? It's an element in what we're sorting. So we have to remember to write the function such that it takes one argument, and then its return value determines how that element will be sorted. So this value must be sortable. And the value doesn't need to be of the same type as the input, right? We saw that before where we were sorting on strings. Len took a string, but it returned an integer. That's totally fine. So as long as the value is sortable that we get back, and as long as it takes an argument, we're fine. So how about we sort integers by the number of digits? So here my numbers list is 500, 2100, 130, 1040. And I'm going to now say def by digit count of n. So return the len of stir n. So I'm going to turn the number into a string, and then I'm going to get its length, and I'm going to return that length. So what happens when I now say print sorted of numbers, key equals by digit count? And I should add, by the way, this is my own personal convention that I make my key functions named by something, something, something. So it's obvious what they're doing. So what do I get back? Well, sure enough, I get the numbers 1, 30, 40, 500, 100, 2000, 1000. Now you might be wondering, wait a second, why is it 500 and 100? Right? Isn't there something wrong there? Well, no, actually it's not wrong. That's because TimSort is what we call a stable sort. If the values we get for two different elements are the same, then they will remain in the same order. So what we have here is both 500 and 100 return a value of 3 from bidigit count. They both have 3 digits. And so they're considered equal, and thus they will not move. They'll stay in the same order as they were in originally in our numbers list. Well, what about sorting sublists by their means? So I have this list numbers, and it has, of course, 4 sublists in it, and I want to get the mean of each list and then sort it by that. So while I'm going to say def by mean, and I'm going to take the sum of the sum one list and return, divide it by the length of the list. And then I can say print sorted numbers key by mean, and now I get them sorted by the means. Here's another example. What if I want to sort by the number of vowels per word? So here I can say words equals this. Here is a fascinating, scintillating a test. So now I want to sort it. So what am I going to do? I'm going to write my function by val count word. We're going to say we're checking the word, and you're going to see why this is useful in a moment. And then I'm going to say, well, total is 0. All right, I'm going to go through each of the letters in the word. I'm going to lowercase it first and check how many vowels there are and return that total. And then I can just say print sorted words key by val count. So why am I doing this? And why does print really help? Because when I actually run it now, we're going to get a printout. Checking this, checking here, this is checking A. We see that the key function is run once and just once per element in our list. And so we get back the words or a list of words in which the first word has the smallest number of vowels and the last word has the largest number of vowels. Fantastic. What if we want to do something even more interesting? I want to sort file names by file length. So I'm going to have a bunch of file names, and I don't want to sort them by the file names. I want to sort them by the length of the files. Well, I'm going to import some modules, glob, which I really enjoy because it allows me to find patterns of file names, and OS. Oh, it's also useful. And def by file name. What am I going to do? What I'm going to do, I'm just going to run os.stat on that file name and get st size, get the size of the file. So given a file name, I will get the file size. And then I can sort by it. It's just like this, print sort of glob.glob of text, star.text. That gives me the list of files, text files in the current directory. I'll say key equals by file length. And sure enough, here are some files that I use in many of my corporate Python training, and they're now sorted by length from smallest to largest. What about sorting file names by the file's vowel count, meaning the contents of the file and their vowel count? Well, once again, I can import glob and I can say def by vowel count of file name, right? My sort function, my key function can be really complex. I mean, this isn't that complex, but we're opening a file and going through it and totaling the number of vowels in the file. And then once again, all I have to do is say print sort of glob.glob of star text and key equals by vowel count. And sure enough, we're gonna get the file sorted according to how many vowels are in them. Next up, what if I have a list of dictionaries? And this list of dictionaries is a bunch of people, happens to be me and my children. All right. So each dictionary has a first, a last, and an age, 3 different keys and values for each one of them. Can I sort this list of dicts? Well, let's find out. Actually, not so much. You can't just run sorted on it. And the reason is because less than is not supported between instances of dict and dict, meaning you can't say, is this dictionary less than this other one or greater than this other one? You can find if they're equal, but you can't compare them in terms of less than. But we can have a key function. For example, we can sort by age. I can say here def by age d, return d of square brackets age. So what this means is when we apply it to a dictionary, we're going to get back the age. So now if I sort people key equals by age, look at that. I get them sorted by age from smallest to largest. Terrific. What if I want to sort by multiple keys, like first, last name, and then first name? Well, here we can take advantage of the fact that Python already knows how to sort a tuple. And so what I can do is return a tuple, return d last and d first from my key function, and then it's initially going to sort by last name, then it'll sort by first name. And sure enough, if I do that now, print sorted people key equals by last first. Look at that, sorted by first, initially by last name and then by first name. Perfect. Now, why would you even write a key function? Maybe we could do better with lambda. Now, remember that lambda sort of gives us a shortcut. Normally, when we define a function, as we've done in several examples here so far, we use def. And def does 2 things. It creates a function object, and it assigns it to a variable. Instead, what we can do is we can just create the function object and throw it away afterwards. That's what lambda does. So it's a single expression, 1 line long, and I can just say key equals lambda d. That's going to be the argument it gets of d last d first, and we return a tuple. You can't use return in a lambda, so we have to just give the expression of that tuple in parentheses, but that's fine. That works. And sure enough, if I run that, It works great. But people have kind of soured on Lambda in the last number of years, and I would say there are some good reasons for that. So let's try doing something different. I can use operator item getter. An operator item getter is a function that returns a function. So what I can do is I can pass key equals operator.itemGetter of age. And what this means is it's going to return a function that effectively runs square brackets age on whatever element it gets, meaning this will allow us to sort people by age. This is so much easier than we could have done ourselves, and we do less work. So, hey, all the better. I can even give it multiple arguments. If I say item getter of last and first, this is just what I did now, either with my by last first or with my lambda. But again, much easier, and it allows me to ensure that I don't have to worry about writing my own code. Well, what if I want to sort objects? What if I have a person object, and that person object has several attributes, first and last and age, right? And I want to sort by those objects. Can I just sort by them? Well, no, once again, I'm going to get this sort of error. Less than is not supported between instances of person and person, right? And that's because we haven't actually implemented the less than operator. But we can implement it ourselves if we add it to our class definition. Just about every operator in Python, I think even every operator in Python, is implemented at the end of the day as a method. And so if we add the correct method to our class, we'll be just fine. So here, in addition to the dunder init and dunder repr, I've added dunder lt for less than. And so by adding less than, now I can sort the people in my list, and it works just fine. I have 4 people objects, person objects. I can print sort of people, and it works out great thanks to this method. Now, here I've decided to sort by age, but I could have sorted by anything, right? It's up to me when I implement my class how I want to do the sorting. Well, I can also implement equal equals. That's implemented as the method dunder eq. Right, and now I can know whether 2 person objects are equal to each other. Without this, actually equal will not work on 2 person objects. Well, has this really affected things? Not really, not directly. But it means that, and then I can start to get more sophisticated. I can say, for example, are 2 people, is one person less than another? Are they equal to one another? By comparing a list, I can say self.last and self.first, and other.last and other.first, because when you compare, you have yourself and you have the other. So this allows me to check and compare, am I less than or am I equal to another person? Everyone's always trying to compare themselves to other people. Now we've implemented such self-doubt in code. Well, what about other comparisons? Like here, I want to say, is people 1 greater than or equal to people 2? And here Python's going to say, you can't do that. We don't know how to do that. We know less than and we know equal equal. Aha. But now the reason why I wanted to implement equal equal, because I can now use functools.totalOrdering. And total ordering is a decorator in functools that if we apply it to a class, it's a decorator for classes. If we apply it to a class that already has LT and EQ implemented, it implements all the rest of the comparison operators. Greater than equal, less than, well, we've already done less than equal, not equal. So it'll really handle all sorts of other things. And so all you have to do is import functools and add functools total ordering on your class. And assuming you have already implemented LT and EQ, you're good. And now I can indeed make that comparison. Now, why should we work so hard? As of Python 3.7, we actually have something known as data classes, and these reduce the amount of code we have to write quite a lot. And it turns out they can handle sorting also. So I'm going to re-implement my person class as a data class. And so I just have to say from data classes import data class, and now I can say at data class. This is a decorator, and I have to pass order equals true. And if I do that above my person class, this is all I have to do. Class person, firster, laster, agent, done. Now, those are the 3 attributes that the data class is going to know it has to implement. And so I don't need getters, I don't need setters, I don't need init. It's handled all there at the class level by the data class decorator. And so now I can create instances of person, and now I can sort them, and it'll work just fine. But wait a second. Is that really fine? The people here are being sorted, that's true, but they're being sorted by first name and then last name. That's not the way I would want. I want last name and first name. So it turns out that in data classes, where we say order equals true, they're sorted in the order that the attributes were declared. So if you want to modify the sort order, just change your declarations, and that's what we'll do here. I'll say now last, then first, then age. And sure enough, once I do that, then the sorting happens automatically. My class has gotten immensely shorter than what I wrote before, And the sorting works better. I don't need a special sort function. It just works in sorted. Fantastic. And we see the results there. So Python's sorted function lets you sort anything. And the key to this working is the key function. Any function or method that takes an input and returns sortable output is game. You can write your own function. You can use lambda. I love using operator item getter. It makes things so much easier. And classes are sortable if they define some magic methods, but you can even make it easier with data classes. All right. Thanks so much for watching my talk. If you have questions or comments, please don't hesitate to email me, Reuven@LearnerCoil, or you can follow me on Twitter, where I post frequently about Python, and I'm happy to answer questions. Thanks again. All the best, and enjoy the rest of the conference.